Okay, so we're going to be talking about this cycle. Let's talk a little bit about this cycle. So first of all, the first exercise that you did was developing that statistical question. The statistical question is simply the question that you want to answer, exactly. And what can it be? Literally anything you want to know, you want to have information about, right? And so we use statistics a lot to be able to answer these questions. But to do that, we want to make sure that we stay focused. We need to develop a good plan, right? A statistical plan. We need to think about the question that we're going to ask. We're going to think about what we're going to do to gather the data. Again, we talked about how randomization is important because it helps to balance the bias and get rid of confounding variables. Okay? So when you're dealing with your statistical question, you're going to start with your purpose statement. What do you expect to achieve? And remember, they did that a certain way. I wonder, blah, 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 right? So it's very important that you have a good statement, a good question. Then you're going to restate your purpose statement as an investigative question. If I do this, then what's going to happen? What do I think is going to happen? Okay? Or I think this will happen. And then you're going to have a comparison before and after, right? As well as a control and a test group. You want one group to be your control group, another to be your test group. So you need all of that. And finally, you need to require evidence that a response variable in order to infer a possible answer. So think about what you think the action is going to get, right? So that was your first exercise. And so we looked at, let me just flip through. I forgot we can't. Let's just look at a couple of these. So what they've done is they've given you a couple of examples or a couple of scenarios that you could use to be able to design an experiment. And now, when you're first looking at this, it may look a little odd because they just give you a statement. You could pick anything about the statement that you like to create an experiment, but it has to answer some of those questions. So look at, So you have to have an investigative question, explain what the explanatory variable, the response variable, the population, and also your predicted outcome. Right? So hopefully we wrote those up. Did anybody decide? So let's just look at number 5. What affects people's accuracy at estimating another person's height? In this experiment, participants will be given a photograph from a control set and a treatment set and asked to estimate the height of the person in the photo. Anybody want to guess what kind of experiment could you be getting here? What kind of question could you be asking? Anything? Well, but you're not going to memorize people's heights, right? So
it's like the accuracy of maybe I don't know. They're doing something in the photo. They're giving a random set of photos.
So you're going to be given some random set of photos, perhaps, but you could also control it, couldn't you? Okay. Well, all right. Just think about looking at a photo. Can you accurately predict how tall someone is in a photo? Yeah. You could, if that photo perhaps was against a certain type of background, you might be able to use background clues for that. But let's just say it's just a headshot or head and shoulders or something. It'd be very difficult, right? But what if one of the groups of photos was of men and the other was of women? Could you draw any conclusions perhaps from an experiment designed like that? So, will you just be guessing, or just say it's from shoulder up?
People would probably estimate women as being shorter than men.
Yeah. Culturally, we would probably estimate that the women would be shorter than the men, right? So, now, does that what if they were all men, though? Would that give us a good clue? Are there some clues, though, to how tall or somebody might be?
An old person, they might be shorter because they shrink.
Yeah, so, yeah.
And a young person won't be as tall as a middle-aged person.
There you go.
Age.
Certainly, right? You wouldn't expect, I'm sorry, I'm here. So you wouldn't expect an adult male to be shorter than a child, right? Okay? So age could have something to do with it. So lots of things could affect the people's accuracy at estimating another person's height. So we might design an experiment where we wanted to know, by looking at photographs of different men, could you estimate their height? Okay? So then we could have our variables. So let's look at, so what could the variables be? So what kind of things might affect your guessing? The person's age, right? Okay. Right? Are there things about body shapes that maybe you could use, that you could think?
Also, like ethnicities, if someone looks Swedish or something, you might think they're tall, because Swedish people seem to be tall.
Sure, that there are different ethnic groups. Different ethnic groups may have different heights, certainly, and that may be a culture. There may be something ethnically there. Good. Okay. All right. So, how could we then? Right. If you're going to be looking at that, let's see if I can make this bigger. Clearly not. Okay. So then what about a predicted outcome? If you wanted to make a predicted outcome from that statement, what do you think is going to happen?
That people are probably not going to be very accurate assuming height, because if it's just shoulders, like you can't really guess how tall a person is from shoulder down.
Okay, so from the photo that you're given, right, it may be very difficult to determine someone's height. Okay, now let's do this a different way. Let's say that we have a photograph of the entire person. How good do you think you'd be at?
Better, because you can like look at things around them.
Okay, again, you could get clues from the context. But what if they're standing in front of a screen, so there's no context, just the person standing there? Do you think you could?
Their body type might like suggest if they're tall.
So their body type might.
Their feet, if they've got big feet, they might be tall.
So you might get other clues from looking at shape, body shape, yeah?
Or
So they're
comparing
okay.
it to the photos maybe.
Okay, so you might look at the other photos and make a comparison if you're allowed to do that. Good. So you can design some experiment that would allow you to be able to see those different factors and see if it has an effect. Now, could you do something now just give us a hypothetical population. So let's say we need a population for this experiment. Well,
1,000.
okay, so we want 1,000 people. Okay. Now, you're designing this experiment. You're going to go out and perform this experiment.
Are we?
You,
This is a hypothetical.
right? It's a hypothetical you, but you're going to go do it. So, how realistic do you think, if you are performing the experiment, is asking 1,000 people to look at 15, 20 photographs?
Not very
Realistic.
because there's one of
More
you
realistic than
2,000.
2,000.
Okay. So you want to increase it because to more people?
No.
Okay. It would take a lot of time, right? Okay. So before the end of this term, or before this thing is due, do you think you could ask 1,000 different people to look at 15 photographs and do it?
No.
Probably not. So let's narrow our focus a little bit. So who could I use as a potential population?
The school.
Yeah, you've got a captive audience, don't you? So we could use the school. Now, who do you know best in the school?
Different things.
Probably other year 13s, right? So my population could be year 13 students at Queen Margaret College, right? Okay. Now, so do you see that it's well defined, though, as far as who you're going to ask? It's realistic, right? I'm not going to say everybody in India. It's not going to happen, right? So make sure that it's realistic and well defined, okay? Right? What about if you have, and so we talked about the predicted outcome. We've talked about the population. We've talked about the kind of question that you might ask, right? So you're just going to look at some of these, and I'm noticing lots of blanks here, but so you might look at some of these and come up with some ideas about how you can design an experiment. So let's look at number 6 and just do the same kind of thing that we just did. So what affects a person's accuracy in the passage of time? So have you ever sat somewhere and thought, well, I know you've sat somewhere and thought this, because you've all been in a class, right? When is the bell going to ring? It seems like I've been here 1,000 years, right? So how accurate are we at predicting time? And do you think that varies? So think about an experiment that you could design. First of all, a question. So just gave you a really good one there, didn't I? What could your question be? I wonder. Okay. Well, how about I wonder how well students can predict the remaining time we have in class. Right? So it might, yeah. So think about some of the things that might affect that. So if you started at the very beginning of class, people know how long the class answers. So is that gonna provide some good answers, good data for you?
You have to get rid of every single form of clock and time possible.
Right. So with the designer experiment, we'd have to make sure that they don't have time, they don't have clocks or anything to work with. Right. So would you do that experiment in a classroom situation maybe?
Unless you take all the phones, shut the blinds, get rid of the clock.
It'd be difficult to control all the outside stimuli there, right? So it might be a little more difficult. But you could pull people in and say, estimate the bell is going to ring in 15 minutes, and you could give an estimate somehow, or you could do it during a study period when they don't have class, maybe, or something could happen.
Or maybe you could make it like shorter in a way, like you drag people in a room and be like, I'm gonna set a timer for 30. I'm gonna set like you're gonna do a stopwatch for 30 seconds. I want you to tell me when you think 30 seconds. And
There you go.
We actually did that as kids at school. The teacher would say, and like everyone close your eyes in a minute's time, 2 minutes time, put your hands up, and then whoever got it right, like I don't know what happened then, but.
Excellent. That'd be an excellent experiment. So just give you a certain amount of time, and then raise your hand when you think you're doing. But make sure that. But what was the key to that?
Closing your eyes.
Well, but you said what did everybody have to do?
Close your eyes.
Yeah, right. Because you have to control the visual clues. So, would you think you'd have better results designing that experiment if you did it in a classroom with a bunch of people all in the same room, or would you think you'd have better chance of getting good results if you took everybody into a little room independently?
I mean, if your eyes are closed, I can't see what people are doing. But people can cheat.
All right. You never cheated?
No.
So just think about those kinds of things. I think that I can't, right? But what if you don't get the opportunity to have, hours and hours and hours of the people? We only have you guys in here for a short time, so maybe I'm just going to have to deal with the fact that I'm going to have to trust that you've got keep your eyes closed, right? I don't have time to take you out to do certain things. Okay, excellent. So what do we expect to happen, do you think? Do you think people are good at it, bad at it? What do you expect to happen? Now remember, your expectations are just based on what you think. You don't have any data yet. What do you think?
I think we're more accurate than guessing the person's height.
I'm sorry, what?
It'll be easier to do than guess the person's height from a photo.
Okay. So you think that it's a fairly easy task, though? Okay. So maybe easier than compared to some other things. All right. Do you think some people are going to be better at it than others? Certainly. Okay. All right. So your predicted outcome, and you need to define your variables. Okay. So you see what those scenarios are for. There are two of them. I want you to look through those and go through like we did and design an experiment. I've got this idea. What question could I answer? What do I think will happen? What are the response variables, and what are the other variables involved? Okay? Then you read through about planning the experiment. Okay? Anything stick out to you there? What's important? Anything that struck out to you? What did you highlight in that section when you read it? Anything? Were there any definitions or key phrases? Sorry? The placebo, right? A placebo is when you give a treatment that actually isn't a treatment, right? So you fool people into thinking that they've had the treatment. Anything else? What else did you highlight in that section? Okay. How about all of those different ways that you can design the allocation or distribution of the people? Did any of you think that was important? Number of ways to make the groups comparable. Random allocation, randomized block allocation, matched pair design. So is there only one way to make a random sample? No, there are lots of different ways and methods you could do it. And why would you pick one above the other, perhaps? What might be a factor that would make you do one way instead of another? Could the question you're asking have anything to do with it?
Yeah.
Sure. Could your population have something to do with it? You bet. So you pick the best way for the population and the question and the experiment that you've designed. Okay? All right. Then we talked about, and we looked at this in our other studies, we talked about single blind and double blind experiments. Single blind means who doesn't know what's happening?
Only
The participants in the study, right? Double blind means who doesn't know what's happening? Yeah, no one knows. The person who's administering it, right? As well as the people who are participating in
Why
it.
would the experimenter not want to know what's happening?
Okay? I'm going to get $1 million from the New Zealand government if my study proves that y'all learn better in a dark room.
Oh, that's why.
What's going to happen?
You want to.
I'm going to cheat like crazy because I want that $1 million, right? So, yeah, there can be bias on the part of the administrator in that they're designing questions or making sure that they get the answers they want, right? What do you guys do all the time in class?
Cheat.
Not cheat. Oh, no.
Well, I hope you wouldn't cheat.
Y'all are doing it now, though.
What, listening?
Lose focus.
Well, think about what's happening. I assigned you some questions to do, right?
Laziness.
Did all of you do them and write down the stuff that we're supposed to do? No. Instead, y'all are here waiting for what? For me to answer the questions for you, right? So it's human nature. When we don't know what someone's expecting from us, we want them to feed us the answers, right? So if I want you to behave in a certain way or answer in a certain way, then I can pretty much get you to do it, right? Could I just tell you something and then you'll think, oh yeah, that sounds good, and write it down because that's obviously what I want, right? Well, that can happen in an experiment as well, right? But do I have to tell you the right answer all the time? No. I should? No. Oh, or maybe I shouldn't be telling you the answer. Maybe you should have done it yourself. Just putting that out there for you there, kids. Okay. So let's look at the next one. So let's look at our other questions here. Okay? So look at question number 9. Sorry, let me line this up a little bit so you can see what question I'm looking at. So, when you have a Band-Aid or a plaster on the hairs on your arm, what happens when you pull it off? Sure, it hurts, right? Okay. So, in this experiment, we're talking about describe how you would design an experiment to reduce the natural variability between the control and test or treatment groups, okay? So think about some of the things that happen. So when you have a Band-Aid or a plaster pulled off the hands of your arms, should it be pulled off fast or slowly to reduce the pain? Do we all have opinions about that?
Yes.
Yeah, most of us have an opinion. Want it done fast, or some of us just can't stand it. And just, right? So we want to find out which one's better. So they designed a study. So the Year 12 mathematics class of 25 has agreed to participate. We want to identify possible confounding variables and explaining why they may affect it, and design an experiment so the confounding variables are evenly distributed between the control and the test groups. Okay? So what do you think might affect the outcome? Sure. What?
Like hair.
You bet. Some people have more hair on their arm than others.
Hair than hair.
Right?
And then also, like when you do it on your body, maybe.
Okay, well, we're just going to put it on your arm, right? Okay, so so let's just talk about that one variable, right? Everybody agree that's a confounding variable.
Yeah.
So how could we mitigate that?
Shave people's arms.
Shave their arms. Yeah, we're probably not going to be able to do that. But,
Okay, maybe we'll like the place of a head that doesn't have hair, like not much hair.
okay, or how many arms do you have?
So,
So couldn't I do it fast on this side and what?
Don't you feel
Slow on that side?
different sides of your body?
Yeah.
Is that true?
Isn't it the one that closest to your heart?
It could be a little.
Because
I don't know. That's another confounding variable that we'd have to think about.
because it's like a nerve in your arm or something.
Okay, well that's another confounding variable. That might be something that doesn't work. But if you wanted to find to get rid of that variable, it wouldn't do me any good to use your arm and her arm, right? But if I used each arm and did it each arm, then you would be able to say, "Ooh, that one hurt more than this one," right? And it would be a lot closer than using someone else's arm, wouldn't it?
You wouldn't be able to figure out how much more it hurt, though. You'd just be able to know if it was a yes or no.
Well,
You can't rate someone's pain.
well, no,
There's a pain.
you would have to have the participant rate their pain, right? So on 1 to 10, zip, rate the pain. Yeah?
Then what about people with different pain tolerances?
Exactly. People have different pain tolerances. Some people are like, I don't care, right? But some people, you're not even going to put that thing on my arm because it's going to hurt, right? Have you ever gotten a shot or an injection? When do you start to panic? When you're getting it? When they say they're going to have to give it to you, right? Okay, it starts happening, the pain in this. So, okay? So yeah, different pain tolerances.
I get allergic reaction to them, so I just don't know.
Not good. So how could we account for pain tolerance?
My mum was actually anti-vax.
Anybody?
I don't know. You can't really medicate anything.
Maybe if people know if they have a low pain tolerance, then twice as low.
Okay. Well, you're kind of there. That's kind of a see, right? What is she? Hold on, guys. She said, well, maybe you can get people to tell you if they have a high or low pain tolerance. So what could I do with that information then?
You split them into two groups.
Well, and do I want one with low pain tolerance and one with high pain tolerance?
Or easily mix them.
Exactly. When I'm working on my random sample, I might want to gather some data before I ever put them in a sample, right? We might think about we're going to get a random sample. I want to make sure that I don't get a homogeneous group. So I might ask them a little survey first. And then what if I found out everybody in this group has high pain tolerance? Do I want to use that as my random sample? No. What can I read? What can I do?
You evenly mix the groups.
Well, yep. Yeah, you just shuffle them around again, right? Because we still want it to be random, but you can just shuffle them around again. So you can ask pre-survey questions that would help you understand if a group is in. Now, okay? Anything else about that experiment that you might see as a confounding variable? Anything else might happen?
Only thing I can think of is something like very particular.
All right.
The Band-Aid type.
Okay. All right, ladies. So she's saying, what about? Okay. Hello. So what about the type of Band-Aid that you're using? Are they all the same? You think? Okay. So what would I need to do to make sure that everybody gets the same experience? Use the same exact type for every time you do the experiment, right? So that means that's going to require some planning ahead, isn't it? If I've got 30 people in the group and I'm going to do both arms, then I better buy at least 60, and I better probably buy a few more just in case. Okay? Excellent. Okay, so. All right. Now we went through questions through collecting the data. Yes? How far did we go in these questions? We stopped at... We stopped at question 14, didn't we? Or did we? Or did we go to 19? Okay, so looking at question 14, again, remember the directions. We're supposed to be describing how you would design an experiment to reduce the natural variability between the control and test and treatment groups, right? So let's look at how could we control what's happening here. So what would you do with $4,000? From the list below, indicate how much of the $4,000 you would allocate to each activity. Entertainment, trips, travel, clothing, bank account, music, games. 40 Year 11 students have agreed to take part in the experiment into spending habits. And this is probably a co-ed school, right? If they're talking about 40 general education students. The control group has been told that the money was won in a lottery. The treatment group has been told that the money was saved by them in the last 4 years. Identify any possible confounding variables and explaining how they might affect the response variable. And design an experiment so that the confounding variables are evenly distributed between the control and test group. So, big ideas here. What are the big ideas?
That the control group and the treatment group have been told different things.
Okay, so the treatment group has been told the money was saved, right? And the control group told the money was won in a lottery, yeah? But might the way you spend money be affected by the way you got the money?
Yes.
Which one of us would you... So if you won $4,000 in the lottery, what might you automatically think?
Oh, let's
Free money. This is found money, right? So let's blow it. Let's spend it on something extravagant, right? Okay. But what if you had earned and saved that money by making all A's in your statistics class? You're not getting money for that? Okay. Okay. So what happens if you had earned and saved that money? What do you think? Right. So, but you're going to spend it. We're going to spend it. Okay, guys back there, what do y'all think? So, if you had saved and earned that money, you're still going to spend it. Right? We're not going to save it. We're going to spend it. But what kind of things might you spend it on? Would you be as frivolous?
No.
All right. So how you save the money might affect how you spent it. Yeah. Okay. Sorry about that. Got to change those. Telling me that the next class is coming up soon. All right. So. What else might be a confounding variable? Look at the items that you're spending the money on. Do you think that might be?
All of those things have different price brackets.
So different price things. So like if you're just going to the movies, you got $4,000.
You go see a lot of movies.
You can see a lot of movies for that, right? Okay. Do you all like jewelry? I mean, is it a big priority for all of you?
No.
Okay. And we're in a class that's half boys, half girls.
The guys
Food. Everyone eats.
Yeah.
Eats food.
So, okay. All right. So food. Yeah. So you're thinking about food. Everybody's going to have the same kind of spending on food, you think?
No, some people don't need to eat as much, and other people have dietary requirements.
Yeah, you know somebody who everybody knows somebody who's just like favorite thing to eat is McDonald's, right?
Oh yeah.
But others of you want to go to, I don't know, somewhere nice. Okay? All right, so the amount you spend on food would vary between those. So we got to think about those kinds of things. So lots of confounding variables in this kind of experiment, which seems pretty simple on the face of it, doesn't it? How would you spend $4,000? So, but there are lots of things that you would have to control for and work with. All right, so what I want you to do is go back to these now that we've talked about them and write. Remember that in the grand scheme of things, when this is all said and done, I'm not writing these out, right? So you need to think about them. So this might not be exactly the way you're going to do it because you're going to come up with your own ideas. It's a little more constrictive to have someone else come up with an idea and then you have to come work with those parameters. But if you can do that, then you can certainly work on your own with something, right? If you could take someone else's idea and turn it into an experiment, then you can certainly do your own idea and turn it into an experiment. So that's the exercise here. So they look a little convoluted, but remember that that's good. If you can make something work, then you have a good understanding of it. So go back, reread these, look at the terms and the words, make sure that you're able to pick these pieces out and finish this assignment, right? So next time we meet, I'm going to want to see some of your examples. Not my examples fed back to me, right? So don't do number 14 and say, this is the one I'm going to show you. Right? Pick one of the others, yeah? Now, you don't have to do every one of them to the same level of detail, but pick one of them at least and really dive into it. Okay? One of them from when you just have one of the experiments and you want to see what kind of questions you could ask and what kind of prediction you could make, and then the other from that other section where you were talking about the confounding variables. Okay? All right. Well, let's get started with that then.